To calculate molarity using solute mass, we're just going to put together two concepts that we already know. So we know what molarity is. Molarity is defined as the concentration in terms of moles per liter. So we know that molarity equals the amount in moles divided by the volume in liters. And we know that we can use molar mass as our conversion factor between mass in grams and molar mass. So molar mass is in grams per mole. Okay, so we can use that in order to work out if we got a certain mass of a substance, what its concentration is going to be in a given volume. So we just got to organize what we have. So we have copper 2 fluoride. So we're going to have to work out the molar mass of copper 2 fluoride. ALEKS has actually given us the ionic formula here, but if we didn't know it, we could work it out because it's copper 2, fluoride's always F minus, right? So copper 2 fluoride. Copper has a molar mass of 63.546, if I remember rightly. So molar mass, copper 2 fluoride equals 63.546 plus 2 times fluorine, which is about 19 or 18.998 if I go with the periodic table I've got here. So quickly bash that out. I've lost my calculator. Where did it go? Whoops. So 2 times 18.998 plus 63.546 gives me a molar mass of 101.542 grams per mole. So we're going to use that as an equivalency to convert mass in grams to number of moles. So we're going to go from mass in grams, if I could type, that'd be great, to the moles of copper fluoride. And then we're going to use the volume to get to the concentration of copper fluoride in terms of molarity. So each of these arrows is going to be an equivalency. So the first equivalency we're going to use is the molar mass. 1 mole of copper fluoride weighs exactly 101.542 grams. And then the next arrow, we're going to use the fact that we have the volume equals 350 milliliters. So we're going to divide through by 350 milliliters. And we also have to convert milliliters into liters. So we have to remember that prefix of milli means 10 to the minus 3, okay? So we know that every 1 milliliter equals 10 to the minus 3 liters. So that's going to be my conversion factor that I'm going to use here. Okay, so let's do it. So mass in grams was 0.19 grams of copper. So use the equivalency, which is the molar mass, to convert mass in grams into moles of copper. 2 fluoride. Should finish my sentences really. So if I press equals right now, what I have is I've converted the mass in grams of copper 2 fluoride to the moles of copper 2 fluoride. Okay. So then I need my moles per unit volume. And our volume is 350 milliliters. So I'm going to do this all in one step. Some people do things like moving the decimal point and blah, 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 but that is the road to ruin. Things can go wrong. Remember your unit conversions. What SI unit prefixes means. We know that milli means 10 to the power of minus 3. So 1 milliliter is 10 to the minus 3 liters. Okay, so let's just check that our units are going to cancel out like how we're expecting them to. So our mass in grams is going to cancel. Our milliliters is going to cancel, so we should end up with units of moles per liter, and we know that moles per liter is our definition of what molarity is, so that should work out just nicely. So 0.19 divided by 101.542 divided by 350 divided by 10 to the power of minus 3, which I will now attempt to execute poorly on my phone. I think I have to put the minus before the 3. That's probably gone horribly wrong. I think that's gone horribly wrong. Oh, calculator. There you are, I think. That's better. So while I'm working that out, bonus points. Not for real. People always ask me what my favorite soccer team is, and I say you would never have heard of them. So here is your chance to play a fun guessing game. If you get it, tell me in the comments. Give me something to do with my spare time. Where am I? Is your clue. Okay. That is my soccer team. Not Chelsea. That's my Premiership team. So we're asked for 2 significant digits. So I get like 0.00536 blah, 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 blah. So actually, I'm going to write that out so you can just see how I'm putting this into sig figs, because sometimes people's calculators are like my calculator and spit out something like that. So in standard scientific notation, then, to two significant figures, that's going to be 5.3 times 10 to the power of minus 123 moles per liter. Okay, so, and that is the same as molarity. So italic M. Okay, same thing. Okay, so you guys want to do another one? I guess we can, right? See what else we get. Okay, let's play rinse and repeat. So show another one. All right. Oh, it'd have to give me a fun one, wouldn't it? So we've got a mass in grams of aluminium sulfate, and we've got to work out the concentration of this solution. So let's stuck everything in the bin. All right, aluminium sulfate is going to be a fun molar mass to do. So we've got two aluminiums. Aluminium is 26.992, I think. If I misread that, I'm sorry. It's a very small font. Approximately. We'll be fine. Sig figs will save us. And then how many sulfurs have we got? We've got an SO4. We've got 3 of them. So 3 sulfurs, which is 32, I think, 0.046. Going on like my memory here. And then 0.4 times 3 is 12 times 15.999. So whatever that turns out to be will be our molar mass of the aluminium sulfate. So aluminium sulfate, you should be able to work out that formula just based on the charge of aluminium, 3 plus, and sulfate ion is 2 minus, right? 2 times 26.992 plus 3 times 32.046 plus 12 times 15.999 gives me 342.11 grams per mole. Okay, so we're going to try and convert our mass in grams to the number of moles of aluminium sulfate. And then if we have our moles of aluminium sulfate, we can convert that into our concentration in a given volume. We've been given our volume, okay, of 150 milliliters, so we can get our concentration. And that should be in units of moles per liter, which is the same as molarity. So our molar mass is an equivalency for every 1 mole of aluminium sulfate. I know I forget the parentheses. For every 1 mole of aluminium sulfate, that will weigh exactly 342.11 grams. That's a bit of a mouthful, wasn't it? And then our volume is 150 milliliters. So I want to divide by 150 milliliters, or if you prefer, times by 1 over 150 milliliters. It's the same deal. But I got to convert milliliters to liters, so I need milliliters on the top, liters on the bottom. For every 1 milliliter, that is 10 to the power of minus 3 liters. Okay, so make sure you're using your unit conversions correctly. Okay, so our mass was 73.4 grams. Use the molar mass. Verify that grams is cancelling. So 1 mole of aluminium sulfate. All right, so grams cancels, and then moles divided by volume is going to give me my concentration. So 1 over, in this case, 150 milliliters. So at the moment, if I press equals, my concentration would be in units of moles per milliliter, which would be a concentration unit, but just not the ones that we are looking for. In chemistry, we use moles per liter. So I've got to convert milliliters into liters using my standard SI unit prefixes and my knowledge of them. I know that 1 milliliter is 10 to the minus 3 liters. So just verify that everything is cancelling out as we would expect. So grams cancels out, milliliters cancels out, I get units of moles per liter, which is the same as molarity. So if I stick this in my calculator, 73.4 divided by 3, 42.11, divided by 150, divided by 10 to the power of minus 3, much happier on my calculator, I get 1.430339, blah, 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 blah. We're asked for 3 significant digits, so I guess that would be it, moles per liter, aka 1.43 molarity. Same deal. All right, how about it?